welcome you all again to this course, Machine Learning for All. And this is the part 2 of the implementation or application of your Excel for implementing machine learning model. So in this part 2, we will try to implement some classification type of solve some classification type of problem with the help of some classifier algorithm. So here we consider same data. I already mentioned that there was two output column in that previous data, that we have a problem that we wants to just estimate or predict the success of a movie. So we have already successfully predicted or created some regression models which can predict the earning or the box office collection of the particular movie. And now what we are trying to build, a model which can estimate or to predict whether a particular movie is success or failure based on the label data. So now for that we have already that data set where we have 150 or 149 instances, and we can divide this entire data into two halves and training and testing. So 70% of the data is allocated for training the model and 30% is for testing the model. So first we will be implementing logistic regression model, and then we will go for the KNN type of classifier model. Now before that, let me just create my training data set. So here we are considering 105 data point for training. So I'm just copying this value. So before that, if you just check, these values are all numerical values. Now if you remember the expression for the logistic regression, it has some exponential term. So if I go for the exponential term, these big values will create so much small value that Excel cannot show that particular values. So in that case, what we will do here, we can implement a standardization of the data. Basically what we will do, from the observation, we will try to negate the average value and then divide this entire thing by standard deviation. So that will standardize the data, and the exponential term, it will be not be that much smaller, that Excel will provide, or it will reflect some kind of error while calculating some value. So what we'll do, first let us just standardize this data. So what I can do, so just remove this part or the data set what we have considered. So let us just treat our data set first. So how to treat? We will create separate columns for every feature. So I will use insert, then I will just write standardize budget. So SB is the new feature. So for simplicity and just we can easily calculate the standard deviation of the data with stdev, and you just write all or select all the values. So basically here also we have selected B2 to B150 cell, and then also we can calculate the mean with the help of the formula average B2 to 150 B150. Now we can just standardize the data by just select that particular value minus fix the mean value, which is nothing but 29. So if I just select and just fix them with the dollar sign and divide it by the standard deviation, again you have to just fix that value also. So sorry missing. So we have to just divide this by the standard deviation. So now your data is standardized. Now copy this entire formula or drag the entire cell till last. So you have this kind of value. This one is not required. Now what we will do, so we will just consider or change the form of the or cell type or format it as number, or you can consider as general also. So general will show the numbers properly, and similarly we can just treat YouTube views. So we will create again another column, that is standardized YouTube views. So again we will apply same formula. Now we have to just replace the standard deviation and mean for this column only. So fix the mean and then divide it by fixed standard deviation. So again it standardized the particular value, and again from number I'm just changing the format or cell format to general, so it will show the particular value. Again this is not required. Similarly for another two cell or two columns, two features, we can do the same. Standardize YouTube likes. Equal to, again the same value, minus fixed mean divided by and also here also I'm just changing the setting to general. And finally last, standardized YouTube dislike equal to mean make it general. So now we have prepared our data and we are ready to move to our next step, that is for training, testing, splitting. So already we know the proportion, so we have to just copy paste the initial 105 data points, and remaining points we have to just put for testing. So here I'm just copying this entire data. So first let's say 104 till 105, that is total 104 data point. So these are the films which will be going for my testing, and also we have to just put the standardized values of these numbers. here for the next data set also we will do the same on next day feature. And corresponding output or the labels. So I missed two values, so I have to add another value, so that is 105. So these two values I have to just copy. I missed these two values. Okay. Now after this, just remember, in case of logistic regression, the expression was lny, or the log odd ln p by 1 minus p, equal to I plus or a plus b1 into x1, b2 into x2, b3 into x4, b4 into x, or just mistake. So basically, ln p by 1 minus p equal to a plus b1 into x1, b2 into x2, b3 into x3, and b4 into x4. Now first let us just calculate this portion, and then we just remove log from both sides, as we can consider p divided by 1 minus p equal to e to the power a plus b1 into x1, b2 into x2, b3 into x3, and b4 into x4. So that part we will calculate over here. So exp into we will go for a, that is fixed value. Again I have to just fix this value, then plus, then coefficient for first feature, into first feature value, plus coefficient for second feature. You can fix this, then into second feature value, plus coefficient for third variable or third feature. You fix this and multiply this, and plus last coefficient of the feature, that is p10. So that is, again you just fix it and multiply with the particular cell or the feature value. And once you calculate this, so you found the value, and we just check. So this is the logit value what we got from the calculation. Now we have to calculate the probability of success. So how we can find this probability of success? Now before that, this approach is similar to your regression approach only. So where we initially defined all the coefficient values or intercept values. Let's say here I have defined a, b1, b2, b3, and b4. Then I have initiated or considered the initial value as 0. Why? Because if you are not putting any value or assigning any value, it will consider some kind of a garbage value. And definitely again that same tool solver will be useful to find the solution or find the value of a, b1, b2, b3, b4. But here, instead of minimizing the error, we will try to maximize the likelihood, sum of log likelihood. Now, how to calculate the sum of log likelihood? So, let me just explain one by one. Now, once we calculate the logit or that particular p by 1 minus p ratio, I can easily calculate the probability. So, let us say if a p by 1 minus p equal to that logit, so definitely the probability will be, you just calculate, so p equal to the logit divided by 1 plus logit value. So, that same thing we will implement over here. So, your logit divided by 1 plus same logit. So, it will show some 50% probability right now. So, right now, based on our coefficient, this is the probability of success. Now, what is the likelihood? Likelihood is that if I wants to get that 1, then based on the probability, what is the likelihood of that particular 1? So, chance of getting 1 based on the probability. So, here we will be using the if function or if formula. If your F2 cell equal to 1, because we wants to achieve, we are trying to achieve or trying to maximize here the maximum probability, or we are trying that it should reach to the highest value. So, that is possible value is 1. Then probability of success you can consider, and probability of failure. So, 1 minus that particular probability that you have calculated. So, once you create it, so your likelihood also 50%. So, there is a 50% chance that particular instant your level will be predicted as 1. Now, what is log likelihood? So, whatever value you got, so now you take the ln out of it. So, if you take ln or log, then it will give you the log likelihood. And this sum of log likelihood I want to maximize for my case. So, already I have created this thing. So, equal to, if I put sum for this entire column J, so you can find the value is minus 72.09. Now, just go to the data as previously in the previous regression training we have observed. Open the solver. So, here you select maximization and select that particular cell which you want to maximize, and also you select the variables which you want to tune, and with the help of these variables only you are trying to reach to that maximum value. And you have to uncheck make unconstrained variable non-negative, and you have to select again GRG non-linear and just hit OK button. And if you get, this is the coefficient of regression for your logistic regression you have found. Now, later we will come to this predicted class, how we can predict the class based on the value. Before that, we just try to now use this expression or these coefficient values for testing data set. So, till 105 we have considered as our training data set. So, remaining data now we will be bringing for testing data set. So, same here also we need that data set. So, from here 106 to 150, I am just copying here, and then all the values or standardized values will copy and paste. and for the remaining last feature also we will copy paste. So here so right now no need of this success and failure. Still after prediction only we need this to compare how much accurately we have predicted. So again what we will do, we will calculate the logit. Now here we will calculate logic based on the observed or obtained coefficient values. So I have to use these coefficients over here. So I'm just copy paste all these values of the coefficient in the second sheet. Control C here. Okay, now so I have to go back again, Control C or copy and paste it over here, and done. So I'm just marking this so you will understand these are the values that you have to use to calculate. So again, how to calculate the logit? Come over here. So if you need, you can directly transfer this or directly use those values in the training sheet, in the testing sheet, but here I'm just separately I'm doing that. So first select this one. Again, you have to just fix it, basically the intercept, then plus, so first coefficient or coefficient for first feature, then multiply it with the value plus second coefficient, multiply it with second variable plus third coefficient plus fourth coefficient into this value of fourth feature. So once you hit enter, so you will get the logit value, and now you just drag this for all the cells, so you will get the logit value for every training data points. Now similar to your testing the sheet, you can calculate the probability value by just taking the ratios of logit divided by 1 plus logit. So this divided by 1 plus again 1 plus this is okay. So okay, I just forgot to take the exp or exponential function. So here exp you have to just apply, and then again okay, so here this logit divided by again 1 plus logit. So this are the probability values for the success. Now based on this probability value, I can easily find out the class of the particular case. Now let us just predict what is the class for or category, either success or failure. So now if we consider that my probability is 0.5 or the cutoff probability or threshold is 0.5, means whatever the probability value, if it is more than 0.5, 0.5 or more, then we will consider that particular case as 1, and below it will be 0. So again I will be considering that particular function if this h is column value is greater than equal to or equal to greater equal to 0.5, then you put 1, otherwise 0. Now if you click here, so see it is 0.33, so it is below 0.5, so it will consider as 0, and for 0.97 it will consider as 1. So now how you are defining the threshold, based on that only these values will be estimated. Now let us just put the final value or the success failure factor, the value which was originally leveled in the collected data set. So if you copy, put it over here, now we have kind of a original comparison between predicted or estimated and the original value, and based on this too we can easily now calculate or try to find out what is the performance of my model. Now first for that you have to just remember that four concept of, let's say, false negative, false positive, true positive and true negative. So what is the meaning of that? That you have to just find out how many times you have falsely predicted negative cases, how many times you have predicted falsely positive cases, and definitely the two true cases, where how correctly you have predicted the positive cases, or one, how correctly you have predicted the negative cases. Here we can use the same if calculation for this. So let's say equal to if means if that false negative in the sense that if a case which is 1 and it is predicted as 0, then it is false negative. So in that case, if it is a false negative, definitely 0, that any one case is predicted as 0. So if I just take the difference between these two, that should be 1. So I am creating a logic based on if function. If f1 original value minus the predicted value, if it is greater than 0, then you put 1, otherwise 0. So it will detect all the cases where 1 is falsely predicted as 1. And if you just take sum of this, so here I have already added a sum function, so it will identify how many times you have falsely predicted that particular score. Okay, so here also I'm just removing this one. Okay. So I have missed this one case, so I can just drag these formulas. So okay. Now if I put sum, SUM, and I select all the values, just check how many times we are getting this value. That is 26. Okay, so 26 times this happens, that any positive case is predicted as 0. So now this is predicted 1 and we have predicted 0, so this will be equal to 26. So we got that particular value. Now false positive. False positive means any case that was 0, originally 0, but predicted as 1. So in that case also we can use this if function. So if, so means this original minus this predicted class, if they are less than 1 or then or less than 0, then we can consider it as a true case. So less than equal to 0, because let's say this is the case of false positive. So any case 1 is falsely predicted as 1. Any case that is 0, that is falsely predicted 1. So we don't have any case where it was 0 and it was falsely predicted as 1. Next is the true positive, where both cases or positive cases or success cases are predicted as success. So what we will consider, if both is equal to 2, then this is a case of true positive and otherwise 0. Now here also I am adding, so I got 4 times I have this kind of opportunity where 1 is truly predicted as 1, and last is that both equal to 0. So if means the 0 is predicted as 0 plus predicted value equal to 0, then it is 1, otherwise it is 0. Now again these values should be assigned to this particular confusion matrix. Now confusion matrix is a type of representation of your prediction where you're trying to predict whether you have successfully predicted your ones as 1 or successfully predicted 0 as 0. So these diagonal values are nothing but the true prediction or right prediction, and this diagonal values are nothing but the wrong prediction. So how many times we have predicted 1 as 1, that is 4. So I can just equal to 4 this value, and then how many times I have predicted 0 as 0, that is this one. So now this is our confusion matrix, that is 4 0 26 15. Now based on this we can calculate the accuracy of our prediction model. Now accuracy is nothing but total correct prediction, that is 4 plus 15 divided by a total number of predictions. So that is 4 plus 26 plus 15, so 45. So that is 19 by 45, that is the accuracy level. Again precision is nothing but your if you just check, you have how many falsely predicted your 0 you have, and you add with your true positive case, then you will get, so basically 4 divided by or here it is Q6. So Q6 is this one, so 4 divided by 4 plus 0, that is actually it was 0 but you have predicted as 1. Next one is the recall option. Recall option is the another cell. So here 4 divided by 4 plus 26. So this formula you can just consider for calculating your recall. And finally your F1 score is nothing but the harmonic mean of these two value, precision and recall. So based on these 4 values you can accurately just assess or try to understand how well your model is performing. So this model is accurately predicting the cases 42%, and precision means definitely how well it is detecting that cases of 1, and definitely the recall is indicating how well that actually ones are predicted in this case. An F1 score indicates a balanced measurement of precision and recall, and this F1 score actually very much helpful when you are talking about any bias data, when you are using bias data in training of a supervised model, or basically in case of classification model. And if you just check all these values, accuracy, precision, recall, and F1 score, these values should be within 0 to 1. If it is crossing 1, then definitely there is a error or some mistakes by you while calculating these values. Okay, so this is nothing but the performance measurement of any classification model. And we have here implemented the logistic regression to predict the success of the particular testing data set, or these movies which we considered in the testing data. Now, one important point I should mention, so you can improve this model by tuning this threshold value. So here we consider 0.5, maybe it may happen that 0.4, the 40% probability threshold is providing better result. So if I just change it, just check, your accuracy increases to 0.48. So it was initially 0.41 and now it is 0.48. So definitely by tuning this value or this cutoff probability, you can easily improve the performance of your model, or you can predict more or improve your model accuracy by just tuning this probability threshold value.